Welcome to the Technology Addicts podcast. In this episode, we're diving into an article from the latest issue of Focus magazine, exploring the exciting world of sustainable transportation. Efficient protection for Mode 3 charging stations. The relatively new IEC-62955 standard stipulates that all three phases need to be switched off in order to provide residual current protection on Mode 3 charging systems. New solutions enable this to be done using just one relay, which can be installed directly on the circuit board in order to save space. There were around 7.4 million zero-emission cars on European roads in 2022. And the European Automobile Manufacturers Association expects this figure to reach 12.5 million by 2023. According to Charge Up Europe, most of these electric vehicles, around 75%, are charged either at home or at work. Charging stations that provide charging Mode 3 are the backbone of the charging infrastructure required for this. They offer normal to fast charging speeds, between 3.7 and 22 kilowatts, and run in a three-phase system with 32 amperes at 380 volts alternating current. To ensure they operate safely, a safety feature is built into the overall installation along with a residual current protective device. The IEC 62955:2018 standard, valid since 2019, covers equipment for residual current protection in charging devices for electric vehicles. When it comes to Mode 3 charging stations, it prescribes the use of effective measures to protect against DC residual currents. In other words, it stipulates the use of residual current protective devices. This protective device must switch off all phases, including the neutral conductor. A relay can be used as the protective switchgear, provided that it detects DC residual currents and isolates at no more than 6 milliamperes. For safety reasons, the main relay should be designed as a normally open contact to ensure the power supply to the vehicle is interrupted if the charger fails. Low contact resistances are important in order to minimize losses, and the holding currents for the normally open contact relay must be low in order to guarantee the overall efficiency of the charging station. In the interests of optimizing efficiency, size, and costs, relays that are mounted on circuit boards are advantageous as this avoids the additional material and assembly costs associated with separate switchgear. They also make the design more reliable as there is no need for connection lines between the board base and relay. Circuit board relays that can be used as the main switching element in three-phase systems are a relatively new development. While the use of circuit board relays has so far been restricted to applications with relatively low voltages, the market now also offers highly efficient 40-ampere relays for three-phase systems. These enable all of the switching functions required for a Mode 3 charging station or wall box to be integrated on the circuit board, which not only saves a lot of space, but also means major cost savings. IEC 62955 compliant circuit board relays offer significant opportunities for both AC and DC charging stations. They help designers to create charging systems that can handle higher voltages and power outputs while also meeting increasingly stricter efficiency demands. As such, they also help to further expand the urgently needed charging infrastructure for electric vehicles. Thank you for tuning in to this episode of the Technology Addicts podcast. For more exciting episodes, be sure to follow us on your favorite podcast platform and make sure to check out the show notes.